This section, we're going to talk about graph of equation in two variable. So here, we're going to talk about a little bit of intercept and symmetry. Intercept. We have x-intercept and y-intercept. What does x-intercept mean? X-intercept is when line pass x-axis. That's going to be x-intercept. Y-intercept, and of course, if the line is passing through x-intercept, x-axis, your value of y is going to be 0. The other way around, y-intercept is when graph is passing y-axis, which your x value will be 0. So if I wanted to show you in a graph, so this is x-axis and this is y-axis. Let's say you have a linear equations passing through that graph, and this is going to be the graph touching x-axis. We call this is going to be y-intercept. And your x value for y-intercept will be always 0 and whatever that y value is. This one right here, when graph touch x-axis, we call that x-intercept. And x-intercept, y will be always equals to 0. We're also going to go over testing a symmetry. What is a symmetry? Symmetry is when graph is mirroring. So for example, when the graph is overlapping through y-axis, we call that y-symmetries. When graph is mirroring or overlapping through x-axis, then will be x-symmetry. And we also have origin symmetry. And I'm going to show you using the example. So example 1 is asking to see if we can determine whether the points are on the graph of the given equations. And this is given equations. What does that mean is they wanted to see if you replace x with 2, you will get y value 3. Or if you replace x and y with 2 and 3, it will satisfy these equations. That's what they want you to check. So let's try that. So when you replace x with 2 and replace y with 3, let's see if we end up getting 6. That will be 4 minus 3, which is going to be a positive 1, which is not 6. So that means this point right here, 2 and 3, is not going to be on a graph of this linear equations. What about the second point? So your x will be 2. Your y will be negative 2. Let's see if this is going to give you 6. So that will be 4 plus 2, which is 6. That's equal to 6. It means this point should be inside of the linear line. So we will say this is the solution set and this is not, right? Let's look at the next one. Graph the point plotting. So this is going to be linear equations given. And if we graph the linear equation, anytime when we're graphing linear equation, we're going to end up getting straight line. So they are asking you to graph this linear line by point plotting. So point plotting, we need to see if we can find few points. Because it's straight line, we only need 2 points to draw the straight line. But let me use 3 points to make sure, that will be straight line, right? So third point will be testing point. So x is going to be -1. When we replace it into the equations, y will be equals to 2 times -1 plus 5, which is 3. So y will be 3. That will be 1 point. What other points? I can try 0 and 1 of the positive number, and 1 will be the easier. So you just pick and choose whichever numbers. You don't want it to use the larger number because you do need to graph it. Let's see, if 0, it will be 2 times 0, which plus 5, which is going to be 5. And then when x is 1, you will get 7. And when you graph this, there is 3 points, right? So when x is -1, y is 3, 1, 2, 3. When x is 0, 5. Oh, wait, hold on. Let me go back. 1, -1, 3, so will be this point, right? And 0, 5, and +1, 7. Draw the straight line. That will be your graph for the given linear equations. And because those 3 points give you a straight line, you do know that will be the right graph. When we're looking at the next example, this is parabola. This is quadratic. Quadratic always gives you parabola, either going up parabola or going down parabola. If you understand what shape you're going to get, then it's easier to know how many points you need to plug in. Like the linear equations, right? It will be linear, will be always straight line, right? So we know that we can use 2 points least. Quadratic will be parabola, so it will be at least 3 points. Maybe because this is first time, we can even try 5 points to see a little bit of curve, right? Not the straight line, not the V shape. Because I wanted to use the easy number, I will start with, again, -1, 0, and 1. Maybe I will do -2 and +2 also. Like I said, so I can see a little bit of curvedness instead of straight line. So when x is -1 squared, that will be 1. When x is 0, 0 square will be 0. 1 square will be 1. -2 square is 4. 2 square is 4. So let's draw that. When 0, 0, -1, +1, +1, +1. When 2, it will be 4. So that's how you can see it's little curvy, not straight line. We call this parabola, right? So that's how you're going to graph linear equations and quadratic by plotting the points. Especially when it's a basic, right? If it's not basic, sometimes it's on the other side of quadrants. It could be here, it could be here, so you may end up using different numbers. And we're going to go over later on how we can tell, where will be your vertex of your parabola. Because if you know where is exactly in the middle of your parabola, that will be easier to plug in more points. Example 3 is asking you to find the intercept. Remember, we say we're going to go over intercept, right? So this one, find the intercept of the graph. So the graph is blue. This one look like your x-intercept is going to be -2. Or you can write it -2 and 0, right? That's going to be your x-intercept. X equals 2, -2. You will not have y-intercept because that vertical line will never meet y-axis. This one, this is your graph, right? This is your graph, and it touches right there, and x-intercept and y-intercept will be 0, 0. Or you could say x equals to 0, y equals to 0. That will be x-intercept and y-intercept. What about this circle? This circle, you have few points. It's more than one point. It's touching x-axis and y-axis. So it looked like this point and that point is where your graph is touching x-axis. So you will say x-intercept is going to be, I don't know, it's decimal, so you need to guess, or if it's on your graphing calculator or on the computer systems, you can move around and it will give you whenever your y value is 0. Your y value is 0, your x value become your x-intercept. From bare eyes, it looked like maybe 3.4. And this point right here, maybe, wait, let me point it. This point here look like 3.4 or 5, right? And this point right here will be -1.4, right? I'm guessing, but again, on my math lab or any homework systems, you can move around the points, and whenever your y value is 0, your x value become your x-intercept, right? So this one you could say it's just 2 points, right? So I will use the braces. -1.4 and 3.4. What about y-intercept? Y-intercept will be this 2 point. Look like that's 5, and this is -1, right? So -1 and 5. This is the graph. You have horizontal line and look like it meets when y is equals to 1. So your y-intercept is going to be y equals to 1 or 0, 1, right? Your x-intercept, that will be none because that line will never meet your x-intercept. What about finding intercept from equations? When finding intercept from equation, it's just finding a point when the other variable is equals to 0. For finding x-intercept, your y have to be 0. So when you replace y equals to 0, you need to find x value, which will be x squared equal positive 4. Square root both sides give you plus minus 2. Right? So it's going to be x-intercept of plus minus 2. In order to find y-intercept, you're going to let x equals to 0. So then replace it into the form equations. You get x equals to 0. So let's see. Y will be 0 square minus 4. Y will be negative 4. That will be your y-intercept. What about this one? X-intercept. Letting y equals to 0. So then you get x squared minus 4 over 2x equals to 0. Multiply both sides by 2x. You get x squared minus 4 equals 0. Where x squared equals to 4, x is plus minus 2. So that will be your x-intercept. And for y-intercept, you're going to let x equals to 0 this time. So then y is equals to 0 squared minus 4 over 2 times 0. No matter what you have on the numerator, if denominator is 0, this is going to be undefined. Right? Undefined means there is no y-intercept. The next example is asking what types of symmetry this is, right? So the graph right here is this. This is the graph. The portion is on the part of the graph is on the first quadrant through the third quadrant, right? When graph and it match. In other words, if you're folding this graph with x-axis and then y-axis one more time, then this graph will be on top of this third quadrant graph, right? So in that case, we call this is going to be origin symmetry. Symmetry with respect to the origin, right? So let me write that down. So this is going to be origin symmetry. What about this B? B, the graph right here, right? In the right side of y-axis matches the left side of y-axis. In other words, if you fold y-axis, this graph should be on top of the other side. We call this is y-axis symmetry. And one thing that you need to know about origin symmetry and y-axis symmetry, if it's a y-axis symmetry, we will learn even and odd function later on. Y-axis symmetry is even functions. And origin symmetry become odd functions. Again, we're going to talk about this more in the later sections. What about this one? This one have a graph, half circle, right? Half circle right here. It's just on the first quadrant, not second, third, or fourth. So since it's not going to be matched in the other side, this is going to be no symmetry. We didn't talk about x-axis symmetry. So if I have a circle look like this, where if you fold x-axis where your first quadrant graph matches the fourth quadrant, this is going to be x-axis symmetries. But again, that wasn't there before, right? If I had graph on the third quadrant that matches this circle, right? Like that, that will be origin symmetry. If I had exactly same graph that matches in a second quadrant, that will be y-axis symmetry. But again, it wasn't there. So as it is, it's no symmetry. Let's look at example 5. Test an equation for symmetry. So we can see what types of symmetry it is from the graph. What about from the equations? So basically what you need to do is testing the points, right? So you're going to test the points for x-axis symmetry by letting your y equals to negative y. So testing it, you're going to have 4x squared plus 9 times negative y squared equals to 36. So we're going to replace y, this y right here, with negative y to see if we can get back. If we can get back, it means it's going to be axis symmetry. And when you simplify this, you get 4x squared plus, because you're squaring the negative, you end up getting positive y, which we went back to what it started. So we will say this is x-axis symmetry. What about y-axis then? You're going to let x equals to negative this time. And when you simplify it, are we going back? Let's see, negative x squared, that makes it positive x. Yep, we're going back to where we started. And that's going to be y-axis symmetry. And what about origin? Origin symmetry, you're going to let x and y into both negative. And this gives you what we start. So that's also origin symmetry. So how could it be all three symmetry? Well, I know this given equation right here is circle, where your center is 0 and your radius is 6. And I'm going to show you, we're going to learn later how we're going to graph the circle, but because I already know, this is going to be actually the graph you're going to have. And it kind of makes sense that if it's a circle starting from origin, this matches this line. Wait, let me highlight it. This line right here matches this line. So that's why it is x-axis symmetry. This line right here matches that line, which will be origin symmetry. This line matches this side, which will give you y-axis symmetry. Because it was the circle, start from the origin, it was able to be all types of symmetry. What about the next one? When you're letting y equals to negative y, this gives you y y is equals to, in order to become negative y to become y, you need to multiply both sides by -1. So this becomes negative 4x squared over x squared plus 1, which is not same as what we started, right? So we know this is not XX symmetry. What about if we replace x with negative x? When we simplify that case, we get 4x squared over x squared plus 1, which is same as what we started, right? So we know that's going to be y-axis symmetry. What about origin symmetry? Let's check origin symmetry. Letting y equals to negative and x equals to negative. And when we simplify this, it will be still y equals to, this negative gone because you're squaring it, right? But this negative, when you're trying to multiply both sides by negative, you will get negative 4x squared over x squared plus 1, which is not same as what we started. So obviously we can tell, let's say no, because I don't want you to get confused with x variable. So this one is going to be only y-axis symmetry. So that's how you're going to test what types of symmetry that is, by letting the other variable negative. Let's try one more. I will try x-axis symmetry first, so letting y equals to negative. And then this will give you y equal negative x cubed, which is not the same. It should be positive x cubed, right? So that's no. No x-axis symmetry. Y-axis, still it will be y equals to negative x cubed because you're multiplying 3 times, it will be still negative, right? That will be no. What about origin symmetry? Letting y and x negative. You get negative y equal negative x cubed. When you both multiply by negative, y equals to x cubed, which this one works, right? This is same as what we started. So that was the origin symmetry, right? So the last one is going to be origin symmetry. So these sections we did look at the intercept and symmetries.